Good evening.
Good evening.
Hi, good evening.
Ready with your stuff to teach?
Yeah.
Yes.
Cool. Let's start with some SQL bold thing and then we'll move on to that one. Okay, I'll share the screen. So we did till where? Till. Okay, this is not me. My sister was working on that. Where is it, guy? So we did till lesson 3 yesterday, and then now we're gonna do further. So this is even this data filtering and sorting query results. Even though the data in the database may be unique, the results of any particular query may not be. Take our movie table for example. Many different movies can be released in the same year. In such cases, SQL provides a convenient way to discard the rows that have duplicate column values or attribute values by using distinct keyword. Okay, so since distinct keyword will be blindly removing the duplicate rows, we will learn in the future lessons how to discard duplicate based on specific columns using grouping group by clause. Ordering result, unlike our neatly ordered table in the last few sessions, most of the data in the real database are added in a particular column order. And as a result, it can be difficult to read through. So to help with this, SQL provides a way to sort your results using order by, ascending or descending. Order by clause is specified. Each row is sorted alphanumeric way based on the specified columns way. So if it's alphabetically, it'll go by that. If it's numeric, it'll go by that. If it is a combination of both, then it'll be alphanumeric. In some database, you can specify a collation to better sort the data containing international texts. Limiting to a subset. So limit thing we did yesterday, I think. Another clause which is commonly used by order by clause are limit and offset. Offset is you let's say there are 10 records and I wanted to start from the fifth record. So I want 5 to 10. So that's when your offset is helpful. So you'll set the offset to 5. So it'll skip the first 5 and it'll start from the 5. Next 5. I'll give you the next 5. Which are useful for optimization to indicate database subset. The limit will reduce the number of rows to return, and option offset will specify where to begin counting. So that's your limit, that's your offset. Okay, if you think about Reddit, the front page isn't linked. Each subsequent page can be represented a set of links to different offsets or database using clauses. Okay. So point to be noted, they are generally done last after other clauses have been applied. So it's a best practice to put them at the end and not put it like on top. Okay, so let's see. So we're going to apply those concepts here. List all the directors of Pixar movies alphabetically without any duplicates. So select all from movies without. So we don't want any duplicates. So we'll say distinct, distinct. Spelling correct? Distinct. Let that go. Distinct. Yeah, spelling's correct. So we don't want all. We want just title. Okay, and then we want to order by list all the directors alphabetically by. So we want ascending. Mm, okay. Do we not want it ascending? Why is it? Hmm. Okay, on all the directors, not title. Sorry, now it's correct. So understood this? It's saying list all the directors, but without duplicates. So that's why I put distinct here, and then the column name from movies, order by ascending. But whose order? You have to specify the column name over here. So column name is director. So I want all the distinct directors from movies, and the order should be alphabetically. So that's why I put ascending. So A B C D. You can see that it's in that order. So we have this checked. Let's move on to the next one. List the last four Pixar movies released, ordered from the most recent to the least. So select last four movies released. Title from movies. You want the last four, and you want order from most recent. Okay, order by. So order by is going to be year, year, and is going to be descending, because I want all the movies whose year is like the highest first. So highest first year will be the most recent, and I want the last four. So last four, for that we are going to use limit 4, limit 4, and then apart from that, well, the limit 4 not work. Mm, limit 4 will be the last thing, I think. Yeah, yeah, okay. So yeah, that works. So give me the last four Pixar movies. So for last four, you're putting limit 4, which means it's only going to give us the four records. How it will give us the last four? Uh, because I have said that order by year descending, which means start from the highest year first. Example 22, 2022, then 2021, and give me all the title of the movies. So this is also checked. That's correct. Let's move on to the next one. So limit we have to put at the end. It didn't work, I guess. Will it work if I put here? No, it didn't work. You have to put it at the last. Okay. Then list first five Pixar movies sorted alphabetically. So again, select title from movies and sorted alphabetically. So order by, whose order by? You have to put specify the column name. Order by the title column. In which order? Ascending order, because you want alphabetically. And what do you want? You want the first five. So you put limit, you put five. So that's your first five movies. It's an ascending order. So that's also checked. Let's go next. List the next five Pixar movies sorted alphabetically. Next five. Okay, which means I don't want the first five. So select title from movies. Uh, okay, so you want the next five sorted all alphabetically. So I want order by, whose order, titles order, which order, ascending order, and then I want it to start from the I want the next five, which I don't want the first five. So then you'll use offset, which means start the query from the five, six, semicolon, five. That's not working. Incomplete SQL query. What am I missing? Mm, offset. Oh, you want next five, so that we have to put a limit there. It doesn't want all. Okay. See, now it works. So this is going to start from the fifth one. So you want next five. So give me another five. So limit five. If I don't put this limit, it's saying incomplete query. It's not matching based on what's required in the question. So that's how it works. Any questions on this one? Am I audible?
Yes.
Yes.
Okay, cool. Let's move on to the next one. We'll do one more and then we'll jump on to the other things. So, simple select queries. You've done a good job getting to this point, so well done. Now that you've got the taste, you need to practice writing queries that actually solve problems. So now we're going to combine everything we've learned so far. Okay. In this exercise, you'll work on different table. Table instant contain information about the most populous cities of North America. So this time is they're going to change the table, including their population, geospatial location, etc. Positive latitude corresponds to the northern hemisphere, and positive longitude corresponds to the eastern hemisphere. So it's going to be a bit confusing. Since North America is the north of equator and west of prime meridian, all of the cities in the list have positive latitudes and negative longitudes. Try and write some queries to find information requested in the task. You know, you may have to use a different combination of clauses in your query. Okay, so what is it asking for? List all the Canadian cities and their populations. So you want all the cities, uh, Canadian cities. So country has to be there. Okay, list all the Canadian cities. Okay, so where country equals Canada. So I want all the cities. So select city from table is called North American cities, and where country, was it countries or country? Country. Country equals, you have to put in quote, Canada. Uh, okay, you want the population also. I'm saying you want population also. So what's the column name for population? Population. Okay, so city, comma, population. Okay, so that's checked. Cities and their populations. So I'm saying give me city, give me population where country equals Canada. So in the exam, it's very easy to make mistake. Here it's gonna give you a check mark, and you get to know that it's incorrect. But there you're not gonna do that. So there, be very careful. Read each and every part of the question, and maybe write it down in your own word if you want. Like like I missed population here. So in the exam, just check what all it's asking. Okay, let's go next. Order all the cities in the United States by their latitude from north to south. Okay. Order all the cities by their latitude from north to south. Positive latitude corresponds to northern hemisphere. So it's saying from north to south, which means if the value is positive, it's north. And then as the value progresses down and goes towards zero, it means it's south. The positive latitudes correspond to the northern hemisphere. Okay, let's see. So what do you want? Order all the cities in United States. So there'll be a where clause of United States, and what do we need? We need cities. Probably we need latitude also. Select city latitude from North American cities where country equals United States. Okay, order by we want the highest first, so descending. But which order? I want latitude order, so you have to specify the column name. Okay, cool, perfect. So here it's saying that the positive corresponds to the northern hemisphere, which means higher the positive value, more it is in the north. Lower the positive value, more it is in the south. So it's saying give me from north to south. So that's why a higher positive value is north and lower positive value is south. So this is north to south order, and it was saying this listed down in that order. So we did that, and you wanted the ones in the United States. That's why we said country, and we kind of assumed that because they want us to order in that fashion, it's best to get latitude also listed, so we can see if it's correct or not. I don't think the examiner is going to penalize you in this if you added this. Okay, but if that part is not mentioned in the question anywhere, then it does not make sense to list that. Okay, let's move on to the next question. List all the cities west of Chicago ordered from west to east. So when you talk about east west, it is to do with the longitude, because longitude corresponds to the eastern or western hemisphere. So we'll get to that, but let's start from the beginning. So list all the cities. Okay. West of Chicago, ordered from west to east. This is a bit complicated one. List all cities west of Chicago. So Chicago is here. Ordered from west to east. Select city from uh, order by longitude west to east. Positive longitude corresponds to east, and they want west to east, so it'll be reverse. So it'll be descending. This will be ascending actually. Um, hmm. Should there be a where clause? It kind of starts from Chicago. So, Maya, can you think of this?
I think we need to get um, all the cities that have longitude lesser than Chicago's longitude. I don't know how to do that.
Okay. Uh, where longitude is less than. Hmm. Cities in the west of. Okay, let's review this once again. List all the cities west of Chicago. Maybe west of Chicago, in ordered from west to east. Okay, let's not spend too much time. We'll look at the solution. We are stuck. It's hard coding the value. It's hard coding the value. Okay. I was thinking on the similar lines to hard code, but then fine. So select. This is already done, so that's fine. Let's do largest cities in Mexico by population. Select city in Mexico. City from North American city where country equals Mexico. And it wants largest population, which means order by population descending. And I think you want distinct one. What is that called? Distinct, right? Is or no offset. Limit, not offset. Limit. Limit one. Limit goes to the last. So okay, so list. Okay, two. You want two, not one. Perfect. So list two largest cities. So that's why I put limit two in Mexico by population. So that's why I put population. If you put population descending, it'll start with the highest. So it'll start listing down the highest first, then followed by next highest. But you only want two, so we put limit two. Where we want it in the Mexico country. So that's why I put where Mexico country from this table, and you want just the city. So that's fine. List the third and the fourth largest city by population in United States and their population. So select what do you want? You want city, and you want the population also, comma population from table name. It's so long that I just copy paste. Okay. You want the third and the fourth largest city. So what I'll do is you'll say where first, where you want it from. You want it from the country, which is United States. So I'll say country equals United States. Okay. And I want third and fourth largest cities. So we'll um, set the offset, and we'll start it from the third, and then we'll limit it to 2. My yeah. Uh, so I want the third and the fourth largest cities. Oh, you have to order by also, because then only you'll get the highest. Order by. Order by. Which order by? You want order by population. Order by population descending. Okay. You want two of them, third and the fourth. Why the heck this doesn't work? Okay. Offset 2 means it's going to start from the third. If I put offset 3, it's going to start from fourth. Saying give me third and fourth. That's why I'm saying offset 2. So start it from the third and fourth. Okay. So again, just a recap. I want cities, so I put city there. And you want their population also, you put population there from this table. In where? In this country, so I put where, United States. You want the largest, the word is largest. So to largest, I have to go by order by in descending populations order. Then it says, give me third and fourth. So I have to put the offset 2, so it starts from third. And I want third and fourth. If you would have said, give me third, fourth, fifth, then I would have put the limit as 3. It would have given me that. But see, they're only asking for third and fourth, so that's why this limit is 2. You just want 2, third and fourth. Complicated or easy?
It's easy if you practice.
Correct. So this is pretty good because it make you think, and it'll put this where order by to practice. The more you practice, the better you get. So I would suggest that just the day before exam, practice this a lot. At least go up until join, because that will help you uh, keep things fresh in your mind, and your mind will get better, and you'll think that way. So let's solve one of the exam papers and see how far we are with that. So where is the question paper? This is, yeah. So this is your table. Let's create this table quickly. I'm just gonna do a couple of them. So there are two tables: account, and then there is bank. This has branch code, account number, and phone number. Sorry, account number and name and balance. Account number, name, balance, and this has. I should put it here. And that's your primary key. Primary key. And then branch code, account number, phone. So that's branch code, phone, account number. This foreign key. This must be primary key. List all the account numbers in order of their name. So where does the account number live? It lives here in the order of their name. So this will be like select. You want all the account numbers. So account number from account table. By. So remember the order by, we always want which column do you want to order it by. So column is name. You want to order by name. And which order? We want it in order of the name. So when it must be in the ascending. It's not asking us to make it ascending or descending. By default, we should keep it ascending order. So is this correct?
Yes.
Okay.
We
I'll
could
do one
display
more.
the name also.
Find account number with, yeah, you're right. So comma name. It's better to display the name because it's included in the question. Okay. Find the account number which has got the highest balance. So second, select one account number, and probably I want the balance also because it's talking about balance from account, order by balance descending. So I'll get the highest and I'll limit it to 1. So that way it's gonna give me. So first thing it's gonna do is gonna list down all the account numbers in order of their balance, and it's gonna put it in the highest balance first because we are saying descending. So descending means start from the highest. Ascending means start from the lowest. So we're starting from the highest. Gonna start listing all the account numbers from the top. Now we're saying don't give me everything, just give me one. So it's only gonna give me the one that's highest. I hope that's correct. Am I missing anything, Sumya?
Yes, looks correct.
Okay. So I'm not going to spend too much time on this, but you can clearly see with this SQL Bolt, we are able to solve exam uh, papers pretty easily. So this is going to be very useful to practice. Of course, we'll do joins and stuff, but yeah, mostly I think they'll give you two tables because they want to test your join capability, the capability to use join. So I'm going to stop here. Uh, Probably I'll just save it. Just, uh, database queries. Okay, close this, erase this guy, and put that as a bookmark. So tomorrow we can start from there. Okay, we'll start with Kritika first. Kritika, you ready with the explanation part?
Yes, okay.
Okay, I'll stop share.
Yes. 1 minute, I'm sharing.
Mhm.
Can you see the screen, right? Can you hear me?
Um,
No?
Yes.
I think like
Yes, that's all right. Okay, so binary search tree. So we in our syllabus we have it as binary search tree is being used as index. But I thought like I'll start from the basic. So basically, it's not that difficult. It's pretty simple. So let's say you have a list of numbers, random numbers. What a binary search tree does is that it picks up one number, and like let's say over here it will be if you arrange it in an order, it'll pick the middle number, or it'll pick the middle number, and the middle number, let's say, will be the root, and any number that is equal to or less than that will be in the left, and anything greater than that number would be on the right. So if we pick up 20 over
okay,
here, 10 would go here and 15 would go here. And the way that you continue to check it is by three methods, that is a search, insert, and remove. So if you want to search for a number, this is the way it continues. So 15 over here, 10, this follows the list again. So 8 is less than 10, that's why left side, and this is on the right side. This part
okay,
is called the node, which connects to, and it will always be only two. It cannot be three or more than that, because it's binary, right? So it will always divide it
okay,
only into two parts, and this is called the root. This is called the node, and these the last ones are called the leaves.
mm-hmm.
So if you the advantage of this is that when you start to search, let's say we want to find the number 12 in over
Mm-hmm.
here. So instead of going through each and every number, it'll in the first step it will simply split it into two parts, and then again into two parts, and then again into two parts. And so it's easier to arrive at the number that you're looking for much easily.
Okay,
um, for example, this could be incorrect because uh, you cannot put 16 over here, because even let's say you have 16. So even though 16 is greater than 10, it is still this has to be the largest number. So in this case, if we had 16 as a number, 16 should have been here, and then 10 should have been here, and or 16 should have been here, and then 15, and then the lesser number. So this would be 10, and this would be 8. So the biggest it cannot, this number can never be bigger than this number. um, this is n by 2 is basically what I explained before. It divides it into n, which divides it into n by 2, and then n by 4, and so on. One of the things that we have in our PPT, over here it says B tree is a self-balancing search tree. Self-balancing search tree basically means, oops,
Mm-hmm.
self-balancing tree basically means that it will not never have and the difference between this part, the number of the height in this part and this will never be greater than 1. So for example,
Mm-hmm.
this one on the left side it is 1, 2, 3, 4, 5, 6, and on the right side there's none. So which means that's a huge difference.
Not
So this is
self-balanced.
so this is not a
Mm.
balanced tree. Um, um,
Okay.
yes, yes, and this is also not balanced. So for our binary search tree as indexes, these two are incorrect. It should be
Mm-hmm.
balanced, which means it will be in this format. The the
Okay.
second one that we had here was insert. So let's say you want to insert a number here. Um, let's say you want to insert the number 19.
Mm-hmm.
Again, it will start right from here. It will check whether is 19 greater than 15. If yes, it will go to the right. So now you know
Mm-hmm.
you have to insert over here. Again, it will check with 20. Is this greater than 20 or less than that? So less than that, so 19 will probably come here.
What will happen to 17, which was existing?
It will create another branch downwards. So let's say over
Okay.
here it will become 19, and then left, because it's smaller, it will come 17, will come over here.
But there will be nothing on the right. It will be just hanging there, right?
Yes, it will be hanging there.
Okay.
Right. Yes, like over here. So we have nothing over here. I
Okay.
meant 19 is greater than 17, so it will be on the right. Sorry, I said left before. This way.
Okay. So which means that you're not going to disturb the original position of the elements which were there. Like it could have kicked off the 17, but it didn't.
It
So
could have
you're
picked
just going
up
to follow that,
17.
and wherever it finds a place, it'll adjust. Correct.
Yes, I think
So
so. I
ideally,
didn't
it
think
could
about
have
that.
put 19 there and moved the 17 below
And
that, but it didn't do
17
that.
below.
It's not going to change the original position of the nodes.
Yes, I
It'll just
think so.
find the next available space.
Hmm.
Okay.
Yes.
Can you create a binary tree and show? So let's say go up, go on top,
Mm-hmm. Oh,
just
where,
completely
over
on
here?
top, full
Okay.
where there are a list of numbers. Yeah, you have the 15, 10, 20, right?
Yes. Mm-hmm.
So my question is, are you always going to consider the first number as the root number?
Uh, I think it has a little bit to do with data structures and algorithms as well. So I think the rule is that you choose the last
Mm-hmm.
number first. This is just a random set of numbers. This is not according to the nodes that I showed you. I think we choose this one
Uh-huh.
as the middle number. I mean, there's no reason for it. It's just a convention.
How do we,
Oh,
where do we start from? Like if I am given this set of numbers and I want to
mm-hmm.
construct a binary tree, where do I start from? How do I know where do I, which number should I start from? Should I go from left to right or right to left?
We don't really have that in the book, but
Okay.
but if you still want to like do that, I think the way is to pick up the last number, and then everything will fall either left to it or right to it, and then like split it into half, and then continue to do that. I think that's the way.
So
I'm not fully sure
I'll
about that.
plot 25 as a root.
Yes.
Okay. So my question is, do we plot 25 as a root node, and then I take 17 and I layer it below it and then like this.
I think your voice is breaking for
Okay.
me. I cannot hear
It's
you
breaking
clearly.
for
What's
me
breaking?
too.
Yeah, I think it's an internet connection. I'm just gonna try this. Am I audible now?
Yes.
Hello.
Yes.
Okay.
Hello.
What I was
Yes.
saying is that can you find out how to actually plot these numbers? So if you're given a list of numbers, how do you actually plot it? Where to start from? Maybe you can check that tomorrow.
Yes, I will do that. Okay, I'll do that. I think for this case, they've arranged it ascending order, and then picked up the middle
Mm-hmm.
one and went on that way. So over here,
Okay.
the middle
Okay.
number is 15, and then mm, um, the middle number of these two is 10, and then the middle
Mm-hmm.
number of the last three is 20. So 20 comes
Okay.
here, and then left and right.
Okay.
But I think it's different in data structures and algorithms.
Yeah. So check and let me
Um,
know how they're actually plotting it.
yes, okay.
Cool. But well done with
Okay,
the
and
explanation part.
yes, thank you. And
Okay.
this is from the book.
Yeah.
This is where we say key and address pair.
Mm-hmm.
So again, this is like the actual application of what we just learned. So if you have
Mm-hmm.
like 112 here, less than that, and more than that. So this is 5 and this is 20,
Yep.
and then
Same
again,
process.
right, right, and it continues that way.
Mm-hmm.
Yeah, and then this is another one. I did not fully understand this. It says B positive tree, and the only difference that they say here is that which have all the key values at the leaf level also, which means it has all these values over here, which means it goes on till the very end. I think that's the only difference. Like for example, over here it ends with 120, 115. It does not show as 116, 17, 18. But over here, I think it shows all of those as well. But I am not very sure about this. I don't know what B minus and B plus tree is.
Okay.
If you know, you can like,
I'll find out.
yes.
I'll find out. No
Yes.
problem. Thanks, Kritika.
Thank you.
Welcome. Okay, we'll move on to Sumaya now.
I'll stop sharing.
Yeah.
Yes.
Sumaya, can you hear us?
Yes. Just a
Okay.
second, I'm sharing my screen.
Okay.
Okay, so first normal form relation is in first normal form if every attribute of R takes atomic values. In other words, the following conditions hold in R. There are no duplicate rows or tuples in the relation. Each data value stored in the relation is single valued, and entries in a column or attribute are of the same kind or type.
Okay.
So this is an example of an employee database. The employee mobile column is multi-valued. There are multiple entries in each row. So it's not in first normal form.
Okay.
Uh, so to make
Mhm.
it comply with the first normal form, we have to make separate rows for each mobile number, so that
Okay.
none of the attributes contain multiple values. So the emp ID, emp name, emp address will be repeated for each mobile number that they have.
Okay. So three rules are that the value need to be atomic, uh, which means it should be single valued, not multi-valued. No duplicate rows. When we say duplicate rows, which means the name and everything could be the same, but it should not be like exactly the same, and not all the data
Yeah.
should be the same. Some data can be
Hmm.
repeated. And entries and the data type needs to be same for those attributes. Correct?
Yeah.
Okay, cool, fine.
A relation is in the second normal form if it fulfills the following criteria. The relation fulfills the criteria of the first normal form and all those attributes which are not part of any primary key, meaning the non-prime attributes are fully functionally dependent on the primary keys. So the
Okay.
non-prime attributes are not allowed to be partially dependent on a primary key, or they're not allowed to be dependent on a proper subset of the primary key.
Okay.
Key features of 2NF: the partial dependency will exist only if the primary key is composite. Therefore, if the primary key of a relation consists of a single attribute, then the given 1NF relation would be in 2NF also. So if the primary key is not composite, there's no question of a partial dependency on it. This normal form decomposes a relation so that relations store information
I
about
think I
one
lost
thing.
the network. Can you say that again? I lost the last part from the partial
Uh,
dependency.
if the primary key is not composite, then there is no question of having a partial dependency on it if it's just one attribute. So the relation would automatically be into NF.
So partial dependency will exist only if primary key is composite, which means primary key is a combination of two attributes.
Yes,
Composite means, like for example, name. Name is a composite key because it can contain first name, last name, right?
yes.
So partial dependency will exist only if the primary key is composite. Therefore, primary key of a relation consists of single attribute. Then the given NF would be into NF also. Okay, probably will be clearer with an example.
Yeah. Okay, so here we have a table with teacher ID, subject, and teacher age.
Mm-hmm.
The candidate key is teacher ID plus subject.
Yeah.
So this table is in 1NF because each attribute has atomic values. However, it is not in 2NF because A non-prime attribute, teacher age, is dependent on teacher ID alone, which is a proper subset of the candidate key. So the teacher age is dependent only on the teacher ID and it is independent of the subject.
Right. So
So
because the candidate key is both, the teacher A should be fully functionally dependent on both the keys and not just one. And that is why it is not in 2NF, correct?
yes,
Okay.
so we will have a data redundancy if we have two teachers like here. The teacher age also has to be put twice.
Right.
So we decompose it into two tables. One a teacher table with teacher ID and teacher age, and a teacher subject table with teacher ID and subject. So
Okay.
these two tables are in 2NF.
So now it's in 2NF because the primary key of one table is teacher ID and non-prime attribute, which is subject, is fully functional dependent on teacher ID. First table, teacher's age, which is non-prime attribute, is fully functional dependent on teacher ID. Correct?
Yes.
Okay.
Third normal form. A relation is in the third normal form if it is in 2NF, and every non-key attribute of the relation is non-transitively dependent on the primary key of the relation. So in 2NF, we have no partial dependencies. In 3NF, we should have no transitive dependencies.
Now, what is transitively dependency?
Okay, it will be explained the example on the next slide.
Okay.
Also, a table is in 3NF if it is in 2NF, and for each functional dependency, X determines Y, at least one of the following conditions hold. X is a superkey of the table, or Y is a prime attribute of the table.
Okay.
So this is another employee database.
Mhm.
Here, emp state, emp city, and emp district are dependent on emp zip. A further emp zip is dependent on emp ID. That makes non-prime attributes emp state, emp city, and emp district transitively dependent on superkey emp ID. This violates the rule of 3NF. So all these things are not directly dependent on the employee ID. They're dependent on employee zip, and employee zip is dependent on employee ID. So it's a transitive dependency.
First, I'm sorry, I'm not still clear on that. Can you explain that once again?
Um, so if two employees have the same zip, then
Mm-hmm.
they will also have the same state, city, and district. So we have data redundancy because of this transitive dependency.
Okay.
So state, city, and district are not, they're dependent on zip and not directly dependent on the employee ID.
Okay. Fine.
So this would be allowed in 2NF, but it's not allowed in 3NF.
Okay.
To make this table comply with 3NF, we have to disintegrate the table into two tables to remove the transitive dependency. So
Mm-hmm.
we have employee table with emp ID, emp name, emp zip. We removed all the transitively dependent attributes and put them in a separate table, employee zip table.
Which were kind of making the things redundant.
Yeah,
That's why we kind of removed them because they were dependent on the zip code and not on
yeah,
the employee ID and employee name. That's why putting them separate.
yeah.
Okay. I think
Your
as it
voice good.
large, as you're moving towards 2NF, 3NF, 4NF, it's getting more complex, right? Because it is supposed to,
Yeah,
the previous conditions of the, let's say if it's 3NF, is supposed to meet 2NF. If it's 2NF, it's supposed to
Mm,
be 1F. So you're just adding those extra conditions, making it quite bad.
yeah.
Okay, go on.
Boy's code normal form table complies with BCNF if it is in 3NF, and for every functional dependency X determines Y, X should be the candidate key of the table.
Okay.
So in this example, we have student ID, subject, and professor. A
Mhm.
subject can be taught by more than one professor, but a professor teaches only one subject. So we have the dependencies, student ID plus subject determine professor,
Mhm.
and professor determines subject.
Okay.
The candidate key is student ID plus subject.
Hmm.
So there are no partial dependencies or transitive dependencies. So it's in 2NF, it's in 3NF.
Okay.
But we have the dependency professor determines subject, and professor is not a candidate key.
Hmm.
So the table is not in BCNF. So
Okay.
the left side of the dependency should be a candidate key.
Okay, which is not.
If you have
So which is not the candidate key.
yeah. So we split it into two tables: a student table and professor table.
Hmm. But the previous table didn't have the professor ID.
Yeah, they've added that. I don't think we need to add professor ID. We could do student ID, professor, and professor subject.
Okay. Let's wait for 2 minutes while the prayer is going on.
I'll be back in 5 minutes.
Okay. Kritika, can you hear me?
Yes, yes,
Let's take
yes.
a 10 minutes break and come back.
Yes, yes, sure enough. Okay.
Should we continue?
Let's wait for 2 more minutes. Is Kritika there? Kritika? Yeah,
Yes, I'm here. I'm here.
let's start then.
Okay.
I made the screen bigger.
Okay. Desirable properties of decomposition, attribute preservation. All the attributes of the relation which is being decomposed should be part of at least one of the decomposed relation.
Wait. Well, is this part of normalization?
Uh, yes, after this we have higher normal forms.
Okay.
Um, all the attributes of the relation which is being decomposed should be part of at least one of the decomposed relations. This
Hmm.
is a necessary condition, otherwise the decomposition will be lossy.
Correct.
Lossless join decomposition guarantees that the join will result in exactly the same relation as was decomposed.
Hmm.
Dependency preservation is another important requirement. If all the attributes appearing on the left and the right side of a dependency appear in the same relation, then a dependency is considered to be preserved. Reduction of redundancy. A redundancy is the cause of anomalies. Normalization results in reduction of redundancy.
Hmm.
Why functional dependency should be preserved. Dependency preservation within a relation helps in enforcing constraints that are implied by dependency over a single relation. In case you do not preserve dependency, then constraints might be enforced on more than one relation. That is quite troublesome and time consuming.
Hmm. I was thinking from tomorrow when the prayer happens, we'll take a break for 10 minutes. We'll do our prayers and we'll come back. Make sense?
Yeah.
Okay.
Yes, that's a good idea.
Yeah.
Higher normal forms are fourth normal form, which is based on the concept of multivalued dependency, and fifth normal form, which is based on the concept of joint dependency. Multivalued dependency occurs when two attributes in a table are independent of each other. Uh, both depend on a third attribute.
Okay.
A multivalued dependency consists of at least two attributes that are dependent on a third attribute. That's why it always requires at least three attributes. So here we have bike model, manufacture here, color. Color and year are dependent on bike model and
Okay.
independent of each other.
Okay.
And both of these attributes are multivalued. So they
How are
have
they
multiple
multi-valued?
roles.
How are they multi-valued if in one column there's only one value? Is it decomposed?
It's not. It's decomposed into first normal form. That's why we have multiple rows with the same bike model.
So before decomposition, it was multi-valued, correct?
Yes.
Okay.
This table is not showing multiple values for manufacture year. There's only one value for each. 2008.
Yeah, that's why I'm asking that how is it multi-valued if the two values are not present in the single cell?
Oh, they don't have to be in a single cell. They'll be in separate cells.
Okay.
And the other attributes
Okay.
information
So
will be
this
repeated in that.
okay. So this is not multi-valued attribute. This is multi-valued dependency. So when the difference between
Yeah.
multi-valued attribute and multi-valued dependency. Multi-valued dependency means the two attributes are independent of each other, but they might be dependent on a third attribute. Correct?
Hmm.
Okay. Okay, go on.
Okay, they're represented like this using double arrows.
Bike model. Once and go back to that. Double arrow manufacturer. So manufacturer here is multi valued dependent on bike model. Correct?
Yes.
Okay. And it's called multi
Uh,
determines instead of determines.
mm.
Okay.
For a table to satisfy the fourth normal form, it should satisfy the following two conditions. It should be in the Poisson code normal form. The table should not have any multi-value dependency. Um, this relation has no functional dependencies but two multi-value dependencies
Project tool and
from,
Project tool.
yes, both are dependent on employee number. The
Employee number
relation,
determines project.
yes,
Okay.
the relation is in BCNF but not 4NF. To decompose the relation into 4NF, you may use any of the multi-value dependencies. So we decompose it into employee project
Hmm.
and employee tool.
Okay.
So now there are only two columns, so there can't be a multi-value dependency in these two tables.
Yes. That's a good example.
Join dependency. If a table can be recreated by joining multiple tables and each of this table have a subset of the attributes of the table, then the table is in joint dependency.
What
It
is
is
a
a
subset? What is the meaning of subset of attributes?
um, meaning like employee number project is a subset of employee number project and tool.
Sorry, I didn't
So
understand. Can you explain that once more?
suppose this is our attribute set employee number project and tool.
Okay.
So in these two tables we have subsets of this attribute set. Employee number plus project is a subset of these three attributes.
Okay. Okay.
Um, it's a generalization of multi-value dependency. For example, join of R1 and R2 over C should be equal to relation R.
Okay.
Join dependency can be related to 5NF, wherein a relation is in 5NF only if it is already in 4NF and it cannot be decomposed further.
Okay.
Sometimes decomposition of a relation into two smaller relations does not remove redundancy. In such cases, it may be possible to decompose the relation in three or more relations using 5NF. Such cases normally happen when a relation has at least three attributes such that all those values are totally independent of each other.
Mhm.
So here we have project, tool, employee, uh, and all of the attributes are independent of each other.
Okay.
So this table has a join dependency because it can be decomposed into three tables: project tool, project employee, and tool employee. And when you join these three tables, you'll get the original table. So we want to get rid of the join dependency to make it 5NF.
Mm-hmm.
So we decompose the relation into these projections.
Three
Project
tables.
tool, yeah.
Could
Project employee, tool, I'm sorry.
okay. Yeah, we can go with any combination, right?
Um, I'm not sure if you can use any combination. You have to be able to get the original relation after joining.
Okay. Fine. Let's keep it to 5 NF. Let's not go further. It's too much, I think. I don't think they will give us anything more than that. I'm pretty confident about it. They're not going
Yeah,
to
I
give us.
think probably only till 3 enough.
Yeah, yeah. So it's good to know, but probably just one day before exam, I'm not going to practice anything after four enough. Okay, cool. So let's stop that. Good job, well done, Sumaya, on that. I'm going to
Thanks.
ask you only to recap when we are recapping this part.
Okay.
Okay. So now we'll start with only doing the. Okay, before I start on the database, I'd like to share something with you guys. So last night I created this data structure algorithm. So we really don't have time, and at least Suma, you have started it, but I haven't started this yet. So I'm just keeping all the questions from the question paper as well as from the assignment. I've only started this. Some tasks I've assigned it to you guys. Just take a look at that. Just paste
Yeah.
the solution if you already have for these, and yeah, wherever possible I'm paste, and sometimes I'm keeping questions for you to check if this answer is correct, because some of you might have already studied this. So just check if it's correct, or we have to put more content. And the last thing we want to do
Okay.
is ensure we last thing we want to do is learn an incorrect answer and put that in exam. It will be waste of time. That's why reviewing our answer is important.
Yeah.
So yeah, tree was here also. uh, so I'm here now, so I'll probably write this to my. Um, what will also be helpful, Kritika, maybe you can do this. Just create a Google Doc. Just copy paste this whole question paper, and then copy paste the assignment questions, and just put the slide number uh, from as an answer. So then when we are practicing, we'll start with the question paper. We'll not look at the answer. Like once we are confident we know the content, we'll only look at the question paper, then we'll start giving the answers as a practice, rather than looking at the slide. I think that will be a better way of looking at things rather than just reading the headings. Okay. Do you think you understood what needs to be done?
Is Kritika there or she's gone?
Is it 7:20?
Yeah.
Yeah, I've added that. Kritika, can you hear me?
Yes, I heard everything. Yes, it is 7:20.
Yeah, just copy paste on Google
Okay.
Doc. Just put the slide number.
Mm-hmm.
You can do that for 207 and 208. No,
Yeah.
not 207, 206 and 207.
Okay. Okay.
Okay. Uh, okay, so let's
There
start.
was one slide in DBMS which I think had the wrong answer.
Okay.
Uh, so I put another slide after it.
Which one was that slide number?
It was about a secondary index.
Secondary index. Do you remember the slide number?
No, let me check.
Secondary index is slide 69. I don't know if that is the one you're
Do you
talking
know how
about.
to go to
Yeah,
a
the one after it, slide 70.
You can do control command F and find
which slide
sec,
number you said?
oh, this is find in document. You can type secondary index.
It's slide number 70.
This answer you're talking about?
Yeah, the next slide I put another answer. So this is from the textbook.
Good. So I'll probably delete this one.
And also, the definition of a secondary key is different in the textbook.
Okay.
It seems
You're talking
different
about
from
secondary
what's here.
index. Talking
Yeah,
about
yeah,
secondary.
secondary index.
wh- Yeah. So what's the definition?
Um, So they're saying secondary index is an index defined on a column that is not the key column. So, for example, name.
Mhm. I think this is
As
taken from the internet. Indexing. Yeah, this is the one. This is taken from here. Secondary index to reduce the size of mapping.
yeah, but in the book it's explained differently.
So the thing is if this is incorrect, or if this is completely opposite or different than what's been explained there, or it's not really what it should be, then of course we should change it.
Yeah. Can you check another search result?
Okay. Yeah, they're not
Here they
showing.
have not explained it much, but I think this is this same definition or similar definition.
As in the book.
Yeah.
Okay. Fine, I'll look at that in tonight. Let me make a note of it. Check secondary index. I'll check it.
Okay.
Okay, coming back to database. Can you add another slide there and put the correct information later on?
Yes.
Okay. I'm going to skip the first slide because advantages, you have it here also. So there's no need to have duplication, right? Uh, so we'll just use this one. Okay. So I'll go over this, and then we'll try to recall as much as we can. Okay, so need or advantage of a database management system. Ease of accessing the data. Uh, in file system, different files are created for each user, which they can access. A DBMS removes redundancy for granting access to users and decides which and how many parts of data is accessible to the database. Storage and management of data. Unlike file system, data can be stored in form of objects. That makes it easier to query. So we have ease of accessing the data, unlike file system where files are created for each user. In DBMS, it removes that redundancy by granting access to users and decides which and how many parts of data is accessible. Storage and management is, unlike file system, data can be directly stored in form of objects, which makes it easier to query. Avoiding duplicates and redundancy. In file system, storage of the file can happen multiple times, wherein data normalization is used in DBMS to avoid duplicate data. Concurrent data accessing. Users can access data simultaneously through different applications. Database integrity. Data should be accurate and consistent. This is implemented by enforcing a check or constraint on the data while it's being entered in or manipulated in a database. Data of a database is not allowed to violate these constraint rules. For example, a constraint on an age, an employee can be between 18 to 70 years only. While entering or modifying the data of an age of an employee, DBMS should enforce this constraint. So, a recap: ease of accessing. In file system, different files are created for each user, which they can access. In DBMS, it decides which and how many parts of data will be given to data access will be given to the user. So it removes redundancy by granting this access. Storage and management. uh, where in file system data can be, yeah, unlike file system, data can be directly stored in form of objects, making it easier to query, avoiding duplicates and redundancy. In file system, storage of data might happen multiple times. In data normalization is used in DBMS to avoid duplicate data. Concurrent means accessing data simultaneously through different application. Database integrity means enforcing checks or constraint by making sure it's accurate and consistent. Kritika, you go over this one more time. Then so Maya will go over this, and then we'll start asking each other.
Um, do you want me to read it?
Yes, read
Yes.
it in a
Okay.
way that you can uh, recall as much as you can.
Okay. Um, Ease of accessing data. In the file system, different files are created for each user, which they can access. DBMS removes redundancy by granting access to users and decides which and how many parts of data are accessible to them from the database. Storage and management of data. Data can be directly stored in the form of objects, making it easy to query.
Yes. So right now you're reading for your understanding, so that you
Uh-huh.
can recall. It's okay if you repeat,
Yes.
but try to get as much as you can, grasp as much as you can.
Yes. Okay. Avoiding duplicates and redundancy. In the file system, the storage of data might happen multiple times, so data normalization is used to avoid duplicate data.
Hmm.
Concurrent data accessing, uh, we use this to access data simultaneously through different applications.
Okay.
Database integrity, it means that data should be accurate and consistent by enforcing checks and constraints. Um, yes.
Okay. Uh, Maya.
Ease of accessing data. In the file system, different files are created for each user. DBMS removes the redundancy by granting access to users and decides which and how many parts of data is accessible to them from the database. Storage and management of data. Unlike a file system, data can be stored in the form of objects in the DBMS, making it easy to query. Avoiding duplicates and redundancy. In the file system, storage of data might happen multiple times. Data normalization is used in DBMS to avoid duplicate data. Concurrent data accessing. Users can access data simultaneously through different applications. Database integrity. Data integrity means the data should be accurate and consistent. This is implementing by enforcing checks or constraints on the data when it's being
Okay.
entered or manipulated.
Okay. So, Kritika, give me uh, one of the advantages.
Concurrent data accessing.
What does that mean?
Users can access the data simultaneously from different applications.
Okay. I hope we are going to be true to ourselves and not look at those slides. Huh? I know we all have the access. This is
Yes,
we are doing this for ourselves,
I'm not
and it's
looking.
okay if we make
Yes,
mistakes. Okay.
yes.
All right. Give me one of them. Another, not the same
Um,
one.
Elimination of data redundancy.
Okay. What is that thing
In,
called?
in Data normalization is used to eliminate data redundancy in a DBMS.
Okay. Okay. Cool. I'll give one now. So data integrity, which means the data must be constraints needs to be enforced to ensure data is
Your
consistent
voice is breaking.
and not duplicates also. Yeah, it's my internet actually.
Okay, it's
Is it
fine now.
very
It's
bad or
fine
can you
now.
manage?
No, it's good
Okay.
now. It's okay now.
Okay. So I spoke about the data integrity where it uses the constraints to enforce that all the checks and rules are followed. to make sure that the data is consistent. For example, an age of an employee must be integer and it must be between the range of maybe 20 to 60 or something like that. Okay, Kritika, give me another one.
Um, um, the ease of accessing data.
Yeah,
uh,
good.
it allows you to access data easily. So since these are not stored as these are not stored as files, but these are stored as objects, which
Good, very
makes
good.
it easier to query. Yes.
Correct, absolutely. Sumaya, it's okay if you don't
I
remember.
can't
So you can
remember,
just say
Ahmed.
that's all right. It's completely fine. Okay, so we did ease of access. We did simultaneously, so concurrent access. We did database integrity. Um, I think we did
Storage.
duplication. Yeah, storage
Yeah,
duplication.
storage
We
is
did
left.
that.
We,
Okay,
we didn't
yeah.
do
So
storage.
redundancy,
I
it
mean,
avoids redundancy.
ease of access of data and storage is different over here. So
Yeah,
storage in what I said was a part of storage. I think that it is saved as files and not object. It is saved as objects and not files.
yeah. No, that is a little different. The redundancy, that is redundancy means that in file system there could be multiple files with the same name in the same folder, but in database management system it uses normalization to make sure there's no duplication. We already covered that, did we?
Yes.
Okay, so what else is left? Simultaneous is done. There was the first one. Did we do the first one, which
Yes,
talks
I
about the
did that
user?
one. Ease of
Yeah.
access of data.
So, like for example, in file system, one user has been given granted access for one particular folder or file, but here in the DBMS, uh, a user it decides what part of that data should be given to a particular user. Okay, so it grants that access accordingly. Ease of access, storage and management, avoiding duplicates, good. Concurrent, we did that. I think we did all of them. We didn't miss anyone. Maybe the order here and there, but we covered everything. So ease of accessing different files created for each user decides how many parts of data is accessible. Removes redundancy. Data can be directly stored in form of object, easy to query. Avoiding duplicates and redundancies. Storage might happen multiple times. Data normalization is used to avoid duplicate data. Concurrent data access. User data can be accessed simultaneously through different application. Data should be accurate and consistent. So I said consistent, I missed the accurate part. By enforcing checks or constraints. Okay. Uh, as you progress through day by day, this will improve. But spending more time on one slide, like in the initial parts of the day, uh, is going to be helpful because what's the point when studying it when we can't recall it in the examination day, right? So it's okay to spend more time initially on slides. Okay, so now we'll move on to three level database architecture. I think the first thing I should do is to get rid of this animation. I'm going to, yeah, move this up. Okay, so we'll go over this. Three levels of database architecture. You have is internal level, conceptual level, and external level. And this is used for data abstraction for different types of users, as far as I can recall. Yeah, for data abstraction, different types. Yes. And three levels are physical or internal level, conceptual or logical level, external or view level. Okay. Kritika, go over it once.
The three-level database architecture was designed by ANSI for
Hmm.
data abstraction for different types of users. The three levels are physical internal, conceptual or logical, and external or view level.
Okay.
Yes.
Sumaya?
Yeah. The three-level database architecture of a database was designed by ANSI for data abstraction for different types of users. The three levels are physical or internal level, conceptual level, and user or view level, external level.
Okay. Okay. Now let's do that. So Sumaya, give me the first level. What's the first level from the bottom?
A physical or internal level.
Okay. Ritika, give me the second level from the bottom.
Logical or conceptual.
Okay, good. And the third level is the user level, okay, or the external level. And what is the use of it? Like, why is it used? Sumaya,
For abstraction.
for different types of users, data abstraction. Okay, cool. Now we'll because we have to, of course, in the examination describe what these guys are. Uh, the best thing or the easiest thing to have the very first point for each one of them is to just talk about where they are in this hierarchy. So for physical, you can say that this is the first level in the hierarchy. For conceptual, you can say that this is the second level in the hierarchy after internal level. You can just fill your content with that information. Then for external, you can say that this is the third level or the last level in the external hierarchy or the top level. So that's how you can fill the content there. Then we talk about what do they actually do. Okay, so what do you think? Do you remember what does internal level do? Does anyone remember? If you don't, it's fine. So
Yes,
let's go over
I
them.
remember. I remember. I remember. It saves files and folders in the hard drive or disks,
Okay, so it decides how the
something like
data is
that.
going to be stored. Yes,
Yes,
you're right.
how the data is
It
stored.
decides
Yes,
how the data is going to be stored.
and
There's
then
one more
the
point.
concept.
Hmm?
Okay.
Go ahead. Go ahead.
Okay.
Go
Yeah.
on.
And then the conceptual and logical level does not care about how the data is stored, but it cares
Yes.
more about the constraints, the structure, um, and yes,
Starts with R.
stuck.
The word starts with R.
I only remember it cares about structures
Which,
and
which
constraints.
okay, let me give you a
The
hint. Which
second
type of
one,
database table we are learning?
which type of
We are
relational
learning data. Yes,
relations? Yes, yes, relations.
correct. Third word was relation. So the structure, relation, constraint,
Yes,
good.
and then the
Technical level.
and the external or view level is how the user is going to see the database. It can be different for different users. For every individual, it can be personalized according to them. So they'll see only what they are supposed to see and not the entire database.
Are you sure you're not looking at the slides?
I am. You want me to turn on my camera? I actually studied this. Mm,
Very good.
even for the advantages, I actually made a whole story about.
Ah,
So the first one is ease of access of data, right? So if I'm extending one hand and I can easily get the data, but
nice.
then I have all the data. I need to store it. So the second one is
Hmm.
storage. And
Okay.
then when I store it, I realize that it's not organized, and I am an organized person, so I
Wow.
need to avoid duplicates. And then when everything
Okay.
is fine, everybody else also comes, and like I have a good database, but everybody else comes, and so concurrent data access. And then now that I have a community, we
Okay.
should maintain integrity.
Awesome. Can you make one
Yeah,
for
so
normalization, because that's biting me every night. I have to
I'm
explain for
not going to
normalization.
forget that.
I know, Maya, because I have asked her like almost twice to explain. She explained the first time and now again, but it's hard for us. So that's why I'm giving you guys some topics, because when you teach, you can only teach something if you know it well. You can't teach that if you yourself don't know.
Mhm. I think for normalization, the videos that Sumaya shared were very helpful. Like they took one example and they continued building it. So
Uh-huh.
I think I understood very well from that
And you
video.
remember
I
it
mean, it
also?
was still not like 100%, but significant. Significant,
Okay, cool.
yes.
No problem. So let's get back
You
on
might.
this. Okay, so we'll move on.
Oh,
Physical
and
level.
I just wanted to say I have a meeting at 8 p.m. today, so I'll have to drop off in a few minutes.
Yeah, that's fine. You can drop it.
Yes.
No problem. That's fine.
Okay.
So you can build on this. Highest level in the three-level architecture describes how the data is actually stored in a database. In the lowest level, this data is stored in an external hard drive in form of bits. Yeah, we forgot this part. In form of bits. Um, and at a little higher level, it can be said the data is stored in files and folders. Physical level also discusses compression and encryption. I don't know how to remember this part. I keep forgetting this. This discusses compression and encryption. Okay. Compressing the data and encrypting it. Okay, fine. Conceptual level is a higher level than the physical level. Purpose of the conceptual level is to define the structure, relationship, and constraints of a database system. Describes how the database is going to appear to the user conceptually, and the relationship between the data tables. Just a repetition of this word, just putting in a different way. Doesn't care about how the data in the database is actually stored. Does this underline helps? This bold and underlines.
Yes, it does.
Okay. External view is the highest level in the level tree closest to the user. It only shows the relevant database content to the user in form of views and hides the rest of the data. So different users can see the database as a different view as per the individual requirements. So only shows relevant database, and different users see different view. Okay. So Maya, do you want to give a quick recap of what each one of these do?
Yes. The physical level stores data as files and folders,
Hmm.
and the
So it
data is
decides
stored
how the
as
data is
bits
going to be
in the
stored
hard drive.
in form of bytes.
Yeah,
Okay.
yeah.
And conceptual level.
The conceptual level does not care about how the data is stored on the hard drive. It
Yeah.
defines the structure and the constraints and the relationships in the database.
Yep. And the external level.
And the external level is how the database appears to different users. So different users
Yeah.
might have different views of the database.
Do we need to show everything to the user?
No, we can show a specific part of the database to a user.
Only relevant to him.
Yeah.
Okay. So asking questions like this is how you will remember this in examination. Because, yeah. Okay, let's move on. Okay, independence. I think you can explain this, Kritika, without even going through this, right? What is data independence?
Uh, Data independent. There are two levels.
No,
Physical.
before we get to the level, let's just understand what is data independence.
Uh, Data independence is it one does not depend. one data does not depend, one attribute does not have to depend on the other one. So in each of the three levels, i- if you change anything in the physical level, it should not affect anything
Correct.
in the conceptual or logical level, and if you change anything in the logical level, it should not affect anything in the view level.
Correct. So in general, first we will talk about in general that a change of data at one level should not affect another level. That's the main thing. Then we get into describing about different levels. Uh, so we'll start from here. So data independence means change of data at one level should not affect another. So we should be able to modify the schema at one level of the database system without altering the schema at the next higher level. Again, this is just a repetition but in different way. Talks about schema. Should be able to modify the schema without altering the next level. The three-level architecture defines a single database system across all three levels. Therefore, different levels must map with each other. This mapping leads to concept of data independence. So this mapping we have to remember. This mapping word. Okay, three-level defines a single database system across all three levels. Therefore, different levels must map with each other. Uh, there are two types of data independence. First is a physical data independence, and second is conceptual data independence. Physical data independence occurs at conceptual level, and conceptual data independence occurs at external or user level. So, physical data independence states that a change at a physical level should not affect the change at conceptual level, and conceptual level states that a change at the conceptual level should not affect the user level. So, these are the 2 points for each. So, 2 points अपने को मिल गया. Okay, it is defined as the capacity to change the internal schema without having to change the conceptual schema. Same thing. If you do any change in the storage size of the database system, then the conceptual structure of database will not be affected. Same thing here, but they are using two different words. Here they're using schema. Here they're using storage size. Why they're using storage size is because physical data talks about storage. That is why. So depending on what that particular level does, you can expand on the second line and talk about that. And okay, it is used to separate. This is another point. Used to separate the conceptual level from the physical level. Physical data event occurs at the logical. I think it's better to just not get confused and keep use the same name as physical. Physical. Few things we need to remember is few words which are getting used over and over again is your schema and mapping. You have to remember these words. So you remember these words, you can easily expand. And without having to change the conceptual schema, again, schema is repeated. Storage size, separate levels. Yeah, because this you can repeat for both the things.
Okay, I'll drop off. Bye bye.
No problem. Bye bye.
Bye, Smaya.
Bye.
Logical data independence refers to the characteristics of being able to change the conceptual schema without having to change the external schema. Logical data independence is used to separate the external level from conceptual level. If we do any change in the conceptual view of data, then the user view will not be affected. Logical data independence occurs at the user interface level. Okay, so Sumaya, can you just give a brief information about this data independence, or do you want to read it first?
I'll try to remember.
Okay.
Uh, so data independence means that each level of the database is are independent of each other.
Mm-hmm.
So a change in the schema of one level should not affect the schema in another level.
Okay. Now let's talk about
Um,
the two types of uh, in data independence.
Physical data independence and logical data independence.
Okay.
So, physical data independence is between the conceptual level and the physical level.
Hmm.
So, any change in the physical level, like in the storage of the database, should not affect the conceptual level.
Okay. And you can again build another point. Any change in that? What's that word? Starts with S.
Schema.
Yeah. You can build the second point using the schema.
Um, uh, a change in the physical level should not affect the schema at the conceptual level.
No, if you change the schema at the physical level, it will not affect the
Mhm.
conceptual level. Okay. I think there
Then
was one. There was one more point for the physical level. It talks about separation. So it separates one level from another, right?
yeah,
So it separates physical level from the conceptual level. It is
yeah.
okay, cool. And then what about the logical?
Logical data independence is uh, between the conceptual level and the external level.
Correct.
So, any change in the schema at the conceptual level should not affect the schema at the external or weave level.
Right. So those are the 2 points. And where does it happen? Which level does this occur?
Uh, at the conceptual level,
No. So this data independence will always occur at one level higher. So see this. The physical happens one step up, which is at logical. Similarly, logical happens one step, which is at external level or the user interface level.
okay.
Okay. Moving on. I'm not going to go through this boring stuff. Okay. Relational database management system. Go ahead and read this.
And RDBMS is based on the relational model introduced by EF Code. For example, SQLMS, SQL Server, IBM DB2, Oracle MySQL, and Microsoft Access are RDBMS.
Okay.
An RDBMS database uses tables to store data. Each table is called a relation, which is a collection of related data entries and contains rows and columns. Each table represents some real world objects, such as person, place, or event about which information is collected.
So what is a relational database management system?
A relational database management system stores data in the form of tables or relations,
Mm-hmm.
and each relation represents some object.
Okay. Who was it invented by or created by?
By EF code.
Okay. Give me examples of some of the RDBMS databases.
Mm, MySQL, IBM DB2, Microsoft SQL
Yeah.
Server. Uh,
Okay.
that's all I can remember.
Yes. Good. So yeah, the relational database management system is based on relational model invented by EF Cord, and examples are MySQL, MS SQL Server, Microsoft IBM DB2, all of these examples. And in RDBMS, there are tables. It's based on the concepts of tables, which contains rows and columns. And there is a concept of having a relation. Each relation is a real world entity. For example, a person, place, object, things like that. Uses table to store data. Each table is a relation which collection of related entries contain rows and columns. Each table represents some real world objects such as person, place, or event, which about information is collected. Okay. Difference between relational DBMS and object oriented DBMS. So in RDBMS, data is stored uh, as entities defined in tabular format. In OODBMS, data is stored as objects. In RDBMS, uh, handles simple data. OODBMS handles large and complex data. Okay. RDBMS entity refers to a collection of similar items having some same definition. OODBMS class refers to group of objects having common relationship, behaviors, and properties. In RDBMS handles only data. OODBMS handles both data and function. RDBMS goal is to keep the data independent from the application program. OODBMS goal is to implement data encapsulation. RDBMS uses primary key. OODBMS uses object key to identify uh, an object in a table. So again, a recap: RDBMS is data is stored in entities in tabular format. Here, data is stored as object. Uh, handles simple data, handles complex data. You have to describe what an entity is. Here, you have to describe what a class is. RDBMS only handles data. This handles both data and function. This keeps data independent. This ensures data encapsulation. Here, this primary key. This is where you have object ID. You want to go through this before we recap?
Yeah.
Okay, so read it.
Um,
Read for yourself. Like,
RDBMS. Yeah.
okay.
In the RDBMS, data is stored as entities defined in tabular format. In
Mm-hmm.
ODBMS, data is stored as objects. RDBMS handles simple data. ODBMS handles large and complex data.
Mm-hmm.
An entity refers to a collection of similar items having same definition. A class refers to a group of objects having common relationships, behaviors, and properties.
Hmm.
RDBMS handles only data. ODBMS handles both data and functions operating on that data.
Hmm.
RDBMS objective is to keep data independent from application program. ODBMS objective is to implement data encapsulation. RDBMS has a primary key which identifies an object in the table uniquely. ODBMS has object ID which represents an object uniquely in a group of objects.
Okay, so let me just first hide this. Apparently, it's not hidden. Animation, slideshow. Okay, so give me what data type does the what type of data does DBMS use? What are data is stored as in DBMS? Hello.
Oh, sorry, I was on mute.
Okay.
RDBMS stores data as entities, and object-oriented DBMS stores data as objects.
Okay. What is the goal of DBMS? What does it aim for?
Um, okay, the objective of object-oriented DBMS is to implement encapsulation, and the objective of
Yeah.
RDBMS is to I don't remember what it was.
15th August. 15th
What?
August. 15th August. What was on 15th? What is why we celebrate 15th August?
Um,
What is another name of 15th August?
Independence Day, but
Okay. What is the aim of relational
keep
DBMS?
data independent.
Correct. Data independence. Now you'll not
Okay.
forget. Okay. So yeah. So one of them, which you say, data independence is the object of DBMS, or ODBMS is data encapsulation. Um, then data is stored as entity in RDBMS. Data is stored as object in DBMS. Uh, Data is stored with the relation in tabular format, having rows and columns in RDBMS. In object-oriented programming, it uses classes, the concept of a class, which has properties and methods. Methods, classes. What else was there? Anything else you want to add? We had the relation, we had classes, we had relation, data independence. There was, what was the last one? Last one was the key, right? What is used in
Yeah, the
RDBMS?
primary key.
In
In
RDBMS?
RDBMS, a primary key is used to uniquely identify an entity, and in object-oriented DBMS, an object ID
Yeah,
is used to uniquely identify an object.
the object. Yeah. Okay. So let's see what we missed. Simple and complex. Yeah. How can I forget this? I was reading on that day. Okay. And then we forgot this one. So two, one we forgot. One is RDBMS handles simple data. So when we talk about simplicity of the data, then we'll use RDBMS. But when we have a complex, large applications, then we'll use ODBMS. And RDBMS only handles data. ODBMS also handles applications operating on that data. Okay, cool. Okay, so I'm not going to go over this. You already know all this. We know all this. Okay, here we go. Relational constraints, type of constraints. See what we have. So on modeling the design of a relational database system, we can put some restrictions. What values are inserted, modified, or deleted in the relation. These restrictions depends on the relational constraints. What are the types of relational constraints? Let's try to recall it before
You're
that.
breaking up a lot.
Integrity constraint. Okay, I'm not able to get. Hello, is it
Yeah, I
better?
can hear you now. Yeah,
Okay. Let's try to remember what was. So one was integrity. Then was it to something to do with index?
key
Types
constraint.
of key constraint,
Types
integrity
types
constraint,
of
and there was one
integrity.
more,
Domain constraint.
domain constraint. Yes, a key, domain, and integrity. So we'll remember from key and then we'll remember from domain. Okay. So let's try to recall what keys are. So key constraint states that none of the key must be unique, and every row must have uh, a key. Basically, key cannot be null. I believe this must be it. Let's go over it. Let's not assume. Domain is the first. So domain states that the key must be composite. No, it must be single valued and not composite, right? Let's see.
Yeah.
So these constraints bind possible values of the attributes in relation to a specific set. So it binds attribute values to a specific set of a given data type called the domain. So binds values of attribute to the domain. Okay. Every domain must be atomic, contain atomic values which cannot be divided into sub values. This means composite value and multi-valued attribute are not allowed. So when we talk about domain, we have to remember atomic, and we have to remember no composite, no multi-valued. That's your domain. It has to be like single valued. Okay. Then in key constraint, each key must be unique. Okay. What's first is a unique. This is because the value of the primary key is used to identify a unique tuple in the relation. So key must be unique. In the below, okay, that's fine. That's just an explanation of that. So key, so for domain, we have to remember it has to be atomic, and it binds the possible values of attribute with the domain. Key has to be unique, and integrity constraints. There are two types. Let me recall it. Referential integrity constraint, and there's one more, right?
Entity integrity constraint.
Entity integrity constraint. So let's try to recall. So constraint means that the values should not be null, and the referential constraint means that when we are having the uh, primary key and the foreign key, then the value of the primary key should exist in at least one of the tuples of the uh, secondary table, like the second table where we have the foreign key. Okay.
Should be the other way. The values of the foreign key should exist in the other table. Right?
Okay. I'll check that. If- Unless you're sure. It states that any attribute of a primary key cannot be null. This is because, so difference between entity integrity is here we talk about the nullness, and in the key constraint we talk about the uniqueness. It says that any attribute of the primary key cannot take a null value. I think there's some red ant which is biting me for a long time. I had gulab jamun today. I don't know, one part of that is dropped somewhere and it's biting me. Okay. It states that any attribute of a primary key cannot take a null value. This is because the primary key is used to identify individual tuple in relation. You will not be able to identify the records uniquely if they contain null value for the primary key attributes. Then referential integrity constraint. This constraint is specified between two relations or tables and used to maintain the consistency among tuples in two relations. It is enforced through a foreign key. A referential integrity constraint is specified in two tables. In this database must not contain any unmatched foreign key values. For example, any value existing in employee ID attribute in the assignment relation must exist. Hey, we don't have that table only. We need to copy paste that table here.
Yeah.
So the R contains values. We don't even know which one is foreign. Okay, so R is not foreign. Anyways, we'll paste that later. Or we'll forget. You want to paste it now?
It was on another slide, right?
Yeah. 32. Where did it go? I
The
think it
table is
doesn't
not there.
have a, yeah, table is not there. We just have to use the same table. R should must exist C in S. Look, so thus you have to clarify you what you're talking about the other way around. What should, can you maybe just make it more cleaner? This is so confusing. This whole thing over here. You make a note of it, and
Okay.
later on, when you have time, just make it more cleaner. It's easier to understand and read. Of course, we understand it, but we should be able to write it.
Yeah.
Okay, so let's go and do a recap. Do you want to read it once before you recap, or you remember it?
I remember, I think.
Okay, so let's go with this. So, what is the meaning of relational constraints?
Uh, Constraints are restrictions put on the
Yeah.
data.
Yes. So we put
Uh,
limitations or restrictions on the data to ensure it is consistent and it is not repeated.
to
What are
maintain
the
data
types?
integrity.
Sorry, to
To
maintain the
maintain
integrity.
integrity.
Okay. What are the types of constraints?
Key constraint, domain constraint, and integrity constraints.
Key domain integrity constraint. Okay. What is a key domain? A key, yeah. So, what is a domain constraint?
Um, a domain constraint specifies that um, an attribute should contain an atomic value, so it should not be multivalued or
Right.
composite, and it should have values of its specified domain or data type.
Correct. Perfect. Uh, the key constraint states that the value should be unique. So no two tuples should have the same primary key. And then we have the integrity constraint. What are the types of integrity constraints?
Entity integrity constraint and referential integrity constraint.
Okay, so entity and entity integrity constraints states that the primary key should not be null. And what does the referential integrity constraint states?
Um, the referential integrity constraint states that when there's a foreign key in a relation,
Hmm.
uh, then it should uh, its domain should be the same as the attribute
Primary key in
as
the
the
other table.
attributes in the other table, in the reference table.
Are all the domains or just the primary key? All them, right?
Just the key that it's referencing,
Okay.
the primary key.
And it should exist at least in one of the rows. That is also thing.
Yeah.
Okay. Cool. The domain constraint binds the possible values of attribute to a specific set. First, primary key is used to identify. So we forgot this statement. So this is because primary key is used to identify a tuple in relation. Entity integrity constraints, referential integrity constraint. Any attribute of primary cannot be null. This is because primary key is used to identify individual tuple relation. Will not be able to identify the record uniquely to contain null value for primary key attributes. Specified. So we also should mention this statement, which is it's specified between two relations or tables and used to maintain consistency among the tuples in a true relation. Import to a foreign key. It's specified between two tables. Again, we are repeating this. We should remove this. We are repeating this statement. In this database must not contain any unmatched foreign key values. If you put this statement, I think this will be clear. Database must not
Yeah.
contain any unmatched foreign key values. For example, any value existing in C attribute in R relation must exist in the C in S relation. And it should be of same domain, right? Where did we put that? We didn't put that. You must have read it somewhere. I have read
Yes,
it
it
also.
was in the textbook.
Okay. How much time we have? 4 minutes. Okay. Why constraint should be defined in the database? Let's see if we can recall anything. Uh, for integrity, uh, for the data protection, what else? Avoiding redundancy. Can you think of anything else?
No.
Okay. Uh, Defining constraint prevents bad data from being entered into the table. So bad data, okay? Preventing bad data. You have to remember that. So if we have constraint check, then we are preventing bad data to be entered into database tables. They enforce business logic. So we think about business when we talk about constraints. So enforcing business logic at database level. One thing I also remember now from business logic is that documentation. It helps in documenting. Provide documentation of important database rules. Okay, that's that. And then enforcing relational integrity between any number of tables. So we spoke about integrity, but we put relational word before that. Improving performance. Okay. Can you think of a way how constraint can help in performance?
Mm,
So I mean, I can't think too much, but all I can think is that if we let him put as much data he wants to put, then he's going to just flood the cell with that much like a lot of information. We probably don't want to do that. We want to limit him. And if we, of course, we have less amount of data, it probably will take more, less time. And because there will not be any duplication, probably getting correct data that way. uh, yeah. Okay. Enforcing uniqueness. So redundancy is something we spoke about. It's okay to use redundancy or uniqueness. It's the same thing. So now let's try to remember. So give me one point about why constraints should be defined in database management systems.
they prevent bad data from being entered into the database,
Okay. Another would be enforcing business logic on the database system. Give me another one.
and they provide documentation
Yeah.
for the
Documentation.
database.
Correct. Another one would be they enforce relational integrity, uh, integrity between different tables. Give me
Mhm.
another one.
They enforce uniqueness.
Yes, avoiding redundancy. That's fine. So we spoke about enforcing business logic. We spoke about preventing bad data. Spoke about documenting. We spoke about uniqueness. Let's see if there was anything else. Business logic, uniqueness, enforcing, preventing bad data, performance. Yes, how can you forget that? Performance.
Yeah.
So prevent bad data by entering into from entering into the table of interest, enforcing business logic at database table, providing documentation for important database rules. They enforce relational. integrity between any number of tables, improving database performance, enforcing uniqueness. That's it. So let's stop here. We are stopping at the slide number 33. And tomorrow we'll start with the, what do you call it? The Java first, because we had to cover a lot of stuff today and I don't want to do too much in a day. That's why we kind of skipped Java, but we have to ensure we don't skip it, because if we skip it, we'll forget what we read earlier. And if we can't retain it, then all the time we spend is wasted. So we're gonna start spending at least half an hour tomorrow to start with the Java recap again, only the important questions, and then we'll come back and revise. So again, we'll revise from the start, and we'll do more. Okay.
Okay.
But I think today's session was very. I mean, of course, all sessions were productive, but today's session was very productive. So well done on
Yeah,
the
it was.
explanation part and the participation.
Thank you.
Cool. Good night.
Okay, bye.